Okay, so hello everyone. The question which we will be solving today is House Robber 4. Okay, and as you can see, the question number is 2560 and it is marked as a medium one, right? Okay, so now let's just read the description and try to solve this problem. Okay, so there are several consecutive houses along a street, each of which has money inside. Okay. There is also a robber who wants to steal money from the homes, but he refuses to steal. He refuses to steal from adjacent homes. Okay. So there are consecutive houses, and there's a robber who wants to steal, but not from adjacent houses. Okay. So suppose if he steals from house 1, he won't be stealing from house 2. Okay. The capability of the robber is the maximum amount of money he steals from one house of all the houses he robbed. Okay. So what is the capability of a robber? The capability of a robber is the maximum amount he steals from one house on his like the robbing streak. Like suppose he started robbing. So the capability of his will be the maximum amount which he robbed from any house. Okay, any one house. Okay, you are given an array. You are given an integer array nums representing how much money is stashed in each house. More formally, the ith house from the left has nums I dollars. Okay, so you are also given an integer k representing the minimum number of houses the robber will steal from. It is always possible to steal at least k houses. Return the minimum capability of the robber out of all possible ways to steal at least k houses. Okay, so what do we understand from it? Like there's a robber and he is stealing money, right? Okay, we need to return the minimum capability. Okay, we need to return the minimum capability of the robber out of all the possible ways to steal at least k houses. Okay, so there's a robber. There are houses. Robber won't be stealing from the consecutive houses, right? Okay, and he needs to steal at least k houses. Okay, what is the capability of a robber? Capability of a robber is that the maximum, right? The maximum which he stealed. Okay, maximum which he stealed. The maximum which he stealed, right? From one house, like from one house on his robbing streak. Like, okay, so suppose he started from robbing, so the capability is the maximum from one house on this robbing streak. Okay, so like see here, capability of robber, all the possible ways, all the possible ways. Like, does it remind us of something? All the possible ways. I guess yes, it does remind us of recursion, right? Because in recursion we can try all the possible ways. Okay, so we can recursively check, right? Okay, okay, sounds good. So let's just take this example and try to solve it recursively. Okay, I have written down the same example here. Here the value of k is 2, I guess. Let, let me just check it once. right? Yeah, it's 2. So the robber needs to steal two houses at least. So suppose robber started from 0 index, right? Okay. So the k will be initially 0, right? Let me just shift it down a bit. Okay. Yeah, good to go. This is the I. This will be the value of k. Initially, he haven't dropped anything, so it will be 0. And then we are going to like increase it. Okay. So suppose he steals. So 2, because at ith position there is 2, right? Here we can see it's 2, comma, like we need to store the maximum, right? Okay. So max of this, right? The max of 2 and the max of all the houses which he's going to steal, right? Because like he can't see max of this, comma, all the houses he's going to steal, right? Okay. If he stole 0, he can't steal 1, right? Because he can't steal adjacent houses. So he will be going for 2. So the recursive code will be going to call for 2, comma, 1 house, right? Because we have steal the house, 1 house. So it will go here, here, right? Okay. So the maximum of, let me just write it as m, and what is at the second index? It's 5. So maximum of 5, maximum of 5, comma, we will be going for 2 plus 1, 2 plus 2, right? Because we can't steal the adjacent houses, so we'll be calling it for 4, comma, 0, because we are decreasing the number of houses. So as soon as we come here, we find that the k has become 0. So what does this mean? This means that we have robbed the required houses. So we return 0 from here, right? So 0 comes here. What is the maximum of 0 and 5? It's 5, right? So 5 comes here, right? Okay. So what is the maximum of 5 and 2? It's 5, right? So we get 5 from here. Okay. So okay. So there will also be a call for here, which we won't be picking the. Okay. So let me just. We forgot to make this call. Okay. So there will another call be made for when we won't be picking this 2, right? So what do? We skip it, right? So it will be called for 3 comma 1, in which we are not picking it, right? So suppose if we're not picking it, so now another again 3 will be picked once, like the element at 3, which is 9, right? Okay. 9 comma, this will be again for the maximum one. 9 comma plus, in this side we are calling the plus 2, right? because we are picking it here. Okay, so 3 plus 2, which is 5, and this will become 0, which means we have robbed our houses, right? Okay, so again k here, it becomes 0. So what do? We just return, right? So maximum of 0 and 9 is 9. So 9 comes here, right? And 9 comes here. Okay, tell me one thing. This was a path. Let me just modify tool. Let me just use a different color for it. Okay. Mm, what can we do here? Okay, let me just use the highlighter here. Tell me one thing, that this was a path. This was no, it's not working great. Let me just change it. What can we do? We can use that. Okay, we can use it. Tell me just one thing. It's working great. This was a path. This was a path or not? 5 came from here and 9 came from here. And this was another path. See, these two were different path or not? Yes. From one path we got 5, right? Let me just write it, okay? From one path, suppose it's P1, we got 5. And suppose from another way or path we can say it. Let me just say it a way because in the question it was way. Okay. So can we say this? These two are both capability of individual path. It's a cap. It is also a cap. Cap means capability. So do we need to return the minimum one? Right. So what can we return from here? We can return here minimum of 5 comma 9, which will be 5. The tree will expand more, right? But I just wanted to show you how the tree is working, right? So here we will be having our answer as 5, which will be the minimum capability. And in the, like, if you want to check, you can check it here also. It's the minimum capability, right? So let me just show you the code also. Okay. So see, the TLE will give, the TLE will be there because of this, right? I have used the DP. Okay, let me just show you the recursive code. Okay, we have called it. I have initialized the DP also. Right? We are doing the memoization here, but it won't be working. If it's 0, we are returning 0. If it's not, suppose the path in which we were walking was not valid, so we return the maximum here. We return the maximum here. Okay, and when we will be picking the minimum, that part won't be considered, right? So as you can see, this is the DP code and it won't be working, but I suggest that you should be trying it, right? Because the DP will be revised for once. Okay, so that's a good one. That I mean that's a good practice that and you should be trying these kind of stuff. Okay. Okay. So we definitely need to optimize it, right? So let me just like if you like clearly like if you read the problem statement more clearly, you'll find that return the minimum capability of the robber. Okay, so minimum. Okay, right. Okay, minimum. And what is the capability? Maximum. Okay. So minimum, maximum, maximum of minimum, minimum of maximum. Okay, we have heard it somewhere, right? Okay. So we have heard it, right? We have solved these kinds of problems. Okay, so where does it point to, right? Binary search. We have solved, you might have solved these kinds of problems, like the aggressive cows, book allocations. These all are these kinds of problem. Binary search, right? Binary search. This is our way of doing solving this problem. Okay, whenever these kinds of problem like minimizing the maximum, maximizing the minimum, we use binary search. Okay. See, here is a simple code of binary search. Okay, so I shouldn't be printing this, right? Okay, this was for the debugging part. Okay, I will be removing it. Okay, we see this is a simple binary search template which we use for solving these kinds of problems. Okay, if the answer is valid, we need to minimize it, right? So we are decreasing the high, and if not, we are increasing the low. Okay, let me come to the valid part. Okay, so what happens? Like, see, if it is less than or equal to capability, right? Mid is the capability here, equal to capability, right? So we can steal it, right? Suppose. Let me just come here. Okay, where is the eraser? Right. Suppose the capability was 5, right? Like we will be checking it from 2 to 2, 3. We'll be checking for answers now. So we need to like have a search space which will be having this. See, what is capability? Capability is the maximum what he can steal in his robbing streak. See, what is a robbing streak? The path, the way. That's what I am referring to a robbing streak. Okay. Suppose, like 9 plus 2, 11, 11 by 2. We will get 5. Okay, we will get 5. Suppose we start from here. Can we steal it? The capability which we are taking is 5. Okay, we can. So, like we go to 3 or 5, we move to 5 because we have steal it. We stole it, right? 5 we can steal it. Yeah, we can. And then we move to index out of bound. So how many houses did we steal? 2, which is equal to k, which means we got our answer. So what should we be doing? like try to reduce the search space. Yes, right? We will be reducing the search space. So high will moving from C. Uh, L was here. Initially the L will be here and H will be here. Now we got our answer, so we move the H here, right? Okay, okay. I think okay. Let me just how should I remove it? Okay, let me just use a different color. Are you getting the point? I think it's clear, right? Once you do it by yourself, you will be clear. Okay, so the capability is 3. Right, we start from here. Can we steal it? Yes. So we should be moving it, right? Okay, we move here. Can we steal it? No. So when we can't steal it, should how much should we be moving by 1? Right? Because you stole it, you can't steal this one, but you can steal this one, steal this one. Right. Okay. So if you didn't steal this one, you can steal this one. Right. Okay. So we should come here and we see. No, it's greater than capability. We can't steal it. So 3 can't be our answer because we were able to steal only one house, right? Mm, right. Okay. So then what we will be doing? We will be moving for K. So the high will come here, L and H, and we will be checking it for 2. So in this case also 2 we can steal. Yes. 3 we can't, 5 we can't, and 9 also we can't, right? Hmm. So that is all. That's what we are doing here. Okay, that's what we are doing here. If we can steal it, we are moving it by 2 and doing the count plus plus because we stole a house. And if not, we are just increasing it by 1 because we didn't steal the last one. And if we stole more houses or equal to the required house, return true. And if we return true, the high will decrease. And if we couldn't steal, we will be increasing our capability to store, like increasing our capability to steal the house, right? Okay. So the answer will be this will be our answer because the minimum capability will be stored here, right? Okay. So as you can see, the code is running fine, and this I guess like the runtime will increase if I just I've printed it somewhere, right? Okay. So this will like not make much impact, but yeah, this is our solution, right? Okay. So yeah, that's all for the code, and have a nice day ahead. The question link and the code link will be in the description box. Okay.